Welcome back, my dear children. After learning about refraction of light, let us get into the next topic called as the effects of refraction that you see in the atmosphere, the atmospheric refraction. And the example that you have to study very well is the twinkling of stars. Now, why do the stars twinkle? Now, before we get into the topic, first you have to understand that the stars twinkle only if you observe the stars from the surface of the earth. In the space, do the stars twinkle? No. The stars don't twinkle when you go into the space. They only twinkle when you are observing the star from the surface of the earth, and it is because of the phenomenon called as atmospheric refraction. Okay, so let us consider a star, and we are here on the surface of the earth. So this will be considered as earth. This will be considered as earth, and we have the star, and this is a person observing the star from the surface of the earth. Now to him, the position of the star will appear a little higher than the actual position. What did I say? For a person who is observing the star from the surface of the earth, to him the position of the star will be little higher than the actual position. Okay, this is the actual position of the star, but for this person the star will be a little higher than its actual position. Why does this happen? It has lot of light with it, but for us, for people on earth, it is very far, so we feel that stars are point source of light. Okay, point source of light. Now when this light, the light which is coming from the star, so let us consider this light, always the direction of the light, straight line. Let us consider this to be the light coming from the star. This light will not come straight on the earth like this. No, this is wrong. What will happen to the light? It will undergo multiple refraction. It will undergo multiple refraction. Why will it undergo refraction? Again, because of the atmosphere. Okay, in the space, vacuum. Whereas when the starlight from vacuum, when it comes into the layers of atmosphere, it will not travel in a straight line. It will undergo refraction, not once, not twice, but multiple refraction. Multiple refraction. The star will undergo multiple refraction because of the layers of the atmosphere. Okay, so to explain it better, I will draw the diagram again. Okay, so let us consider ourselves to be on the surface of the earth, gazing at the stars. Okay, so what will we see? We see the stars twinkling. Now, why do the stars twinkle? The first reason is because the stars are far away from the earth. So, it appears like point source for us. Okay, only for people on the earth. Only for us it looks like point source because the distance is too high. Now, as the starlight travels from the vacuum towards the earth, it will have to undergo multiple times refraction. Why? Because from the vacuum, the starlight has to pass through various layers of atmosphere. You know, no? Troposphere, stratosphere, mesosphere, okay, thermosphere. All those are the layers of atmosphere. So it will have to pass through these layers of atmosphere. So as the starlight reaches us, it undergoes a bend. Okay, so the starlight reaches us in the form of a bend. Now, our brain sees the starlight in a straight line. Our brain will always see this light coming towards us in the form of a straight line. Our brain always interprets the ray of light in straight line. But actually what is happening? It is undergoing refraction multiple times. So it got a bend. but our brain is able to interpret the light coming only in straight line. So we see the star in this position, that is slightly above the original position of the star. So this is the actual position of the star and this is the apparent position of the star. Actually, star is here, but due to multiple refraction, it reaches us in the form of a bent ray. And bent refraction means bent way, but our brain interprets the ray of light coming in a straight line. So when you draw straight line, the way we see the star is slightly above the actual position. Now, will this position remain constant? No. We know that the layers of atmosphere continuously changes. Okay? There is always a movement in the layers of atmosphere. And when there is movement in the air. Okay? Dust particles may be more into this area. Maybe the dust particle increases because this is the layer which is closer to the earth. So if the dust particles are more, it will become more denser. Okay? So from rarer to denser medium, again it will undergo refraction. So will this position of the star remain constant? No. That also changes. Okay. Again due to the mobility of the air and because of the mobility of the layers of the atmosphere. Okay. Then you have to pay attention. As we go above the surface of the earth, so this is earth, as we go above the surface of the earth, we know that the air becomes thin. Okay, there is less kachra as we go above. There's more pollution here towards the surface of the earth. Just above the surface of the earth, the air is denser. Okay, whereas as you go high, the air becomes thinner, means the air density decreases. As the density decreases, the refractive index also decreases. Understood? That means here the bent that happens onto the starlight is less. Whereas this starlight, when it enters denser medium, it will undergo more bent. Why? Because as the density increases, the refractive index also increases. What is refractive index? The magnitude of bending. More bending. More the refractive index, more the light will bend. Understanding? So you will also include this point in your answer. That is, the density of the air decreases with height above the earth's surface. So as the density decreases, the refractive index also decreases with height. So as you go above, the light is able to travel almost in straight line. Okay, almost, not exactly. Again, there are layers, so it will undergo refraction to a lesser extent. But as it enters the denser medium, it will bend more. But our brain sees the things in a straight line. Okay, so we are able to see the star at a slightly higher position than its actual position. Now, will this position be permanent? No. Again, due to the change in refractive index. Okay, so lot of things you have to include in the answer. First, about the point source, that all we discussed. Again, due to the changing refractive index and temperature also plays a role here. Okay, refractive index as well as temperature. Now, just think for a while. As you heat water, as the temperature increases, what will happen to the refraction? Okay, the refractive index decreases. Temperature more, refractive index is less. Consider, if it is hot, means we call it as a rarer medium. Okay, so temperature more, refractive index is less. When the temperature is less in cooler medium, the refractive index is more, because when you cool it, the distance between the molecules decreases. No? Whereas when you heat it, it gets converted into vapor form, right? Just consider water. So in vapor form, the molecules are far away. So light को easily travel करने को होगा. Okay, whereas in liquid form, the molecules in liquid form are close to each other. So light will find difficulty in traveling. So it will bend. समझ में आया? So as the temperature increases, refractive index decreases. As the density increases, the refractive index also increases. Okay, tell this in your mind in your own language, okay, and make yourself understand. Don't just mug it up and write in your exam. So I hope you have understood why stars twinkle. Okay, so when the layers of atmosphere are changing, due refractive index also changing. So sometimes the light is able to reach straight, almost straight. So we are able to see the star brighter. Okay. Sometimes due to lot of rukavat, due to the denser medium, the amount of light entering our eyes is less. So we see the star to be dim. So because of this continuous less light, more light, dim light, bright light, more light entering our eyes and less light, it is always changing. Because of that, we see the stars twinkling. Okay, so I hope you are clear with this answer. Why do stars twinkle? Another important question that you have to consider is, if stars twinkle, why don't planets twinkle? Planets do not twinkle. Why is that so? Okay, first and main reason is, planets are closer to Earth. Okay, planets are closer to Earth. Actually, planets are closer to Earth. That's why we see the planets as extended source of light. Extended source of light. Whereas stars are far away, so it appeared to us as point sources of light. Planets are close. So first reason you will write about the closer. Planets are closer to Earth. That is why we see them as extended source of light. Again, the intensity of the light coming from planet, because of the more size of the planet, because it is closer to the Earth, we see it as bigger. Okay, so let us consider this to be a planet. It is considered to be an extended source of light. Let us consider us to be here, okay, on the surface of the Earth. Again, we are here. Now from the planet, it appears as extended source, no? So from here, one ray, from here, n number of rays coming out. So maybe this ray is reaching us, okay. This ray did not reach. So it should appear like twinkling. But at the same time, to compensate this ray has reached us. Okay. Now again, this ray is not able to reach us. So again, it should twinkle. But to compensate this ray, the other ray reaches us. It is happening because the planets are extended source of light. Okay. First, you will write about the distance. They are closer to us compared to stars. Next, you will write about the extended source of light. Planets can be considered as extended source of light. Okay, so they appear to be a collection of point source of light which can be considered as extended source of light. Because of the changes in the refractive index, the position as well as the brightness of individual point source change. Planets are extended source of light. You see in your textbook, they have used collection of point source. So when you have collection of point source, it can be considered as extended source of light. So a ray of light is reaching us. This ray is not reaching us. So actually it should twinkle. But this ray is compensated by this ray. This ray is able to reach us. So it is not point source, no, collection of rays. So we don't see the planets to be twinkling because on an average there are lot of rays reaching our eyes. Okay. Even though some rays are not able to reach, it undergoes refraction. Here also the refractive index is changing. But on an average, the brightness remains same. On an average, the brightness remains same. The brightness is same. That is why we don't see the planets twinkling. That is why planets do not twinkle. Understood? Next effect of atmospheric refraction can be seen in this phenomenon called as advanced sunrise. Means the sun has not risen, but we can see the sun. Okay, in an advance, no, one day before you wish your friends happy birthday. The sun has not risen till now, but still we can see the sun. That is, we can see the rays of the sun. Now, to understand that, first you have to understand what is horizon. Okay, horizon can be best seen when you go for a sunset or sunrise view. No, when you go, you can see that there is water. Okay, the water and the sun. Okay, so that line that separates the sky from water. That is, here you have the sky and here you have the water. So that line that separates the sky and the water is called as the horizon. Is called as the horizon. To understand advanced sunrise, I will draw another diagram. So please consider this as to be the earth, and we'll consider this to be the horizon. That is the line that separates the sky and the water. No, that is the earth. So this is our horizon. Now, the sun is just below the horizon. The sun has not risen till now. But the rays of the sun, that is the ray of light, okay, it travels above the horizon. As soon as it reaches above the horizon and it gets into contact with the layers of the atmosphere, okay, layers of the atmosphere, what will happen at this point? It will undergo refraction. It will bend. Again, onto the other layer of atmosphere, it will bend. So like that, as we discussed about starlight, the ray from the sun also will undergo a bend. Now, because we interpret the ray of light in straight line, so from here I'll draw the straight line, you see the starlight before the sun has reached the horizon. So we are able to see the sun here. This will be the apparent position, okay, jhuta position, wrong position of the sun, whereas the actual position of the sun is here. So it is again due to the atmospheric refraction. The sunlight gets refracted due to the layers of the atmosphere. So due to the continuous refraction, you see the sun's ray, you see the sunrise before. It is 2 minutes before, just 2 minutes before the actual sunrise, we are able to see the sunrise. So we call it as advanced sunrise. Okay, why does this happen? It is because of the continuous refraction of the sunlight. It is because of the continuous refraction of the sunlight due to the layers of the atmosphere. Okay, so we see the sun 2 minutes before it has already risen. So we see the sunlight above the horizon 2 minutes before. Okay, it is just an illusion. Okay, just an illusion. Same way, after the sunset, you are able to see the sunlight or the sun 2 minutes later. Okay, so we call that as delayed sunset. Delayed sunset. Sun, after the sun sets, again 2 minutes, again you are able to see the sunlight. Okay, so that is called as delayed sunset. So I hope you have understood the atmospheric refraction of light, the application to examples wherein twinkling of stars and advanced sunrise and delayed sunset was discussed. Okay, now in the exam, how you will prepare? You have to prepare the answer for twinkling of stars as given in the textbook, that stars are self-luminous. That whole paragraph you have to write, okay, as given in the textbook. And this diagram can be asked, and they may ask you to label. Yes, maybe here they will put a box and ask you to write. So you have to write apparent position of the sun. Here, actual position of the sun. Now, what can you write about this ray? This is the refracted ray. Okay, refracted ray. Here you will write it as atmospheric layers. Okay, so that may be the question asked. Understood? Okay, so we have covered twinkling of stars and topic called as advanced sunrise and delayed sunset. I want you to write all this in your book. That is page number 76 and page number 77 till advanced sunrise and delayed sunset. Topic should be written as it is in your book and learn it well. Children, as I upload the videos, kindly go through the videos. and let me know whether you understood or not. Thank you, children, and do take care of yourself. Bye.